Hi everyone. First, I'd like to thank you all for tuning in tonight. I know you're all very busy at school, so we really appreciate it. So my name is Yin, and I am a Part 2 Chemical and Materials Engineering student here at Auckland Uni. Welcome to Engineering Futures Evening, her student experience. I imagine a lot of you are at that stage thinking, oh my God, what the heck am I going to do with my future? A couple of years ago, me and all the girls who will speak to you today were once in your shoes. If you've already started researching universities, you'll notice that they offer a huge range of subjects that weren't offered at high school. And to be honest, I still don't know what some of them are, but that's not important because tonight we hope to convince you to study one pretty cool degree at UOA, which is the Bachelor of Engineering. So just no marketing gimmicks, no shameless persuasion, just an honest and unbiased perspective from the students themselves. So here is the overview. Just in a nutshell, tonight you'll be expecting a brief intro to WEN, a talk about each engineering specialization, and finally a Q&A session. So during the evening, you have a question, please type it into the Q&A box at the bottom. I hope you're all quite savvy with Zoom. And yeah, just type in a question and hopefully we can answer it in the end. So let's begin. One of the first things you'll ask is, what is engineering? Because I don't know what it was in year 13, and I'm sure a lot of you are currently in the same boat. So here are a few photos of what us WEN leaders thought engineering was. So we have the classic motorway guy, that's my favorite. And then we have some more hard hatters. We have a hands-on mechanic, maybe something involving, maths, complicated maths, or maybe it's just some dodgy guy in the basement. But it's quite a variety, right? But the truth is that it could be all of these things and more. The engineering is the application of science and maths to solve problems. We use scientific theories and knowledge to create, innovate, and design. So it's quite a broad field. It's involving how stuff works, optimizing, and developing products to better society. So every aspect of our life is essentially touched by engineering. I'm going to give you an analogy which may seem kind of stupid, but it's pretty breakthrough stuff, so bear with me. So here we have Dr. Pam. She is great, she's smart and caring, but I hope you can appreciate that her job is impossible without a hospital. Well, who oversees the construction and maintenance of it? Well, you guessed it, they're engineers. How about the designing of the ventilators and the dialysis machines? You guessed it again, it's engineers. How about the tools and the engines and the machinery? They're engineers. How about the pharmaceuticals and the medicines? Also, engineers. So I'm getting quite excited here, so I'll cut to the main gist, which is number one, engineers, they are a vital part of society. And number two, engineers, they come from many different fields. They work together to achieve a common goal. So this leads on quite nicely to the 9 different specializations offered here at Auckland University. So we have biomedical, chem, civil, computer systems, you get it. So you're lucky because in first year, you will get to try all of them, and then you get a good feel about what you're good at and what you're passionate about. There's something for everyone. So you'll be hearing about each of these specializations from one of the girls very soon. Nonetheless, it can be pretty daunting, hence why we have the Women in Engineering Network to support you throughout your degree. We are an inclusive, friendly bunch of people wanting to give you the best uni experience. As you can see, we hold quite a bit of social events. And on the left, that is the WEN dinner, one of the most anticipated events of the year. We have some social cooking, some yoga, and next slide, we have some professional development as well as workshops. So yeah, this is just an intro. I hope I haven't bored you too much and gotten you a little bit more excited about engineering. It is a highly reputable career. It's challenging, there's lots of teamwork, and rest assured, you do make good money. So I've heard anyway. I haven't made much myself, but it's gonna be fun. Yeah, so please ask questions and upvote your favorite ones. I'm pretty sure you can do that. to avoid too much repetition in the Q&A. It's a Q&A, not the chat box. And also, if you do want a specific person to answer your question, maybe Hannah from Civil, seems quite relatable, then feel free to also add that to your question. You can say, hey Hannah, blah, 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 but otherwise just leave it. And so without further ado, I'm going to pass you on to our first speaker, who is Aditi, and she is representing electrical engineering.
Hi guys, so I'm Aditi. I'm in my 4th year of electrical and electronic engineering. But before I tell you about why it's probably been one of the best decisions of my life, I want to walk you guys through a few projects that I do, just so that you guys get a feel of what it really is like to be an engineer in this field. So the first project I want to show you guys is this prosthetic arm that's like robotic that I made with a fellow engineering science student and a software engineering student. So first of all, the coolest part was the fact that I got to work in an interdisciplinary team. So that meant working with people with completely different mindsets and backgrounds compared to me. The second coolest part about this was the fact that we made this completely from scratch. So everything you see was made by us, from 3D printing the finger parts, the palm parts, to doing all the wiring, to doing the coding. Everything was completely made by us. And I don't know, it's probably one of the projects that I'm the most proud of. What really makes this project special, though, is the fact that it's so connected with real life. For me personally, I'm very much interested in the philanthropic and the humanitarian sides of engineering, and this project kind of aligned with those aspirations. So I think it's really cool because the skills I learned in this project can be easily applied to, you know, me going to and serving a marginalized community where people don't have the privilege of being able to afford prosthetics and help them out. So it really like talked to that side of me, which is why this has been one of my most favorite projects. The second one is a smart fan. So this is just kind of to show you how high tech engineering is. Literally, your imagination is the limit. So this smart fan is, it goes faster when you're closer to it and slower when you're further away. And it's something that I invented. Engineers create things that don't exist yet, and that's really, really powerful. So I think people underestimate just how creative engineering is. They like remember all the math stuff, but they forget that it's actually design. So that was a really cool project. The last one I wanted to share with you guys was a computer program. So in this project, I did not know how to do the coding for it. I did not know how to do the graphics or even how games worked. But the greatest part about engineering is that it doesn't just teach you skills like how to build a bridge or how to do circuitry. It teaches you how to learn, how to be a quick learner, and how to be curiosity driven. And that's why you see so many engineers doing really well in fields that are not engineering as well. It's because it kind of improves you as a person and the way you approach problems and challenges. So the fact that I could make this game was a huge accomplishment for me. And I think you'll realize that if you do decide to pursue engineering, it's a very, it's a degree that makes you really proud. The second aspect I want to talk about is jobs. So I know that like this really influences people's decisions, and it should. Engineers are very much in demand. So I had the opportunity to work with Jacobs, which is the world's top consultancy firm in the world. So this was a huge opportunity for me. And what I really loved about this job was the fact that I could work in an office on a desk, but I could also go outside. So I had that diversity and versatility. I went to Whirianga and did a safety inspection and actually made a report that was given to a client. So you're starting to impact the community in your 3rd year of engineering. And that might sound like a lot of pressure, but it really like plays into that whole like philanthropic, changing the world kind of attitude I had when I decided to pick engineering. So I've made like 80 drawings, which are all getting made right now, which is really cool. There are also a bunch of other companies that you could be working for through electrical and electronic engineering. And I know a person, like one of my friends have worked at any of these companies, which shows that it's like really realistic to be working at these really top tech companies that exist. So yeah, there are lots of jobs. But the best part about engineering is the social life. It's the community. So unlike lots of other degrees, which are super competitive, engineering is totally not like that. Like, I still remember that one time I was really like confused about one of my assignments. So I just went to labs, asked this guy next to me who turned out to be a fourth year, and I was first year at that time. And he just helped me out. And I think that really like encapsulates what engineering as a whole is as a cohort. And also we have the best parties. So keep that in mind. The last thing I kind of want to say is the reasons I picked it. So I really picked it for 3 reasons. The first one was that I wanted a lot of versatility in my job. I didn't want to be stuck in one place talking to the same people. I wanted to do lots of things, and I wanted to have lots of change. So engineering. The second thing was I really wanted to do something that was curiosity driven, science driven, that was kind of creative. And engineering was like that perfect mixture between like theory and creativity. So I think it really, like, for someone like me, it was probably the best option. And I think the third and most important reason that I really love engineering was the fact that I wanted to contribute to something meaningful. And engineering really allows me to do that. From within 2 years, I'm already in the workforce, shaping the way our communities work. And I think that's really powerful. And that's kind of what I wanted from my degree, which is why I'm here and telling this stuff to you guys. So if you ever need to contact me, there is a bunch of links. You can contact me through anything. I don't really mind. You can also look at my website. That's more of a CV, but yeah, that's me.
Thanks so much, Aditi. Next up, we have Lola from software.
Hello, I'm Lola from software. Yes, and I would love it if we went on to my slide. That is awesome. So hi guys, my name is Lola. I'm a 4th year software engineering student. I'm originally from Dunedin, but I moved up to Auckland back in 2017 in order to study engineering. So obviously this was something I really wanted to do, otherwise I wouldn't have traveled halfway across the country. So for me, in year 13, I had no idea what I wanted to do. I'm sure like a lot of you guys, I had a broad range of interests and I could see myself going into a bunch of different fields. For me, there are a couple of things that convinced me to do engineering. One of them was that I thought physics was fun. I really enjoyed physics in school, and it was kind of like, all right, so what can I do with physics that's not just going to be theoretical? I wanted to do something practical that I could implement in real life and I could do as a job. So for me, engineering made a lot of sense. Contrary to a lot of people who do engineering, I don't like maths that much. So if you're sitting there and you don't like maths, or you're not good at physics, or you never took chemistry, seriously, don't let that stress you out. I worried way too much in first year that I didn't know enough or I wasn't good enough, but don't let that hold you back, because the awesome thing about engineering is that there is a specialisation for everyone. Yeah, and there basically is something for everyone. So another reason I chose engineering, it sort of goes off what Aditi was talking about, and it's because I wanted to help positively contribute to the world. So sort of as an example for this, and I had an internship a couple years ago at a company called Education Perfect, which creates like an online learning platform for high school students. So you guys might have used it before. And I felt like when I was doing that job, I felt really satisfied in the fact that I was actually contributing to something in the world, and I was helping kind of make the world a better place. So I feel like that is a really positive aspect of engineering. And I worked there as a software developer, just in case anyone was wondering. So now I'll talk to you guys about software engineering and what it actually involves. When I first came to uni, when I first came to study engineering, I had no idea what specialization I wanted to do. And I'd never done any coding before in my life. So if you're sitting there and you're thinking, I don't know how to code an app, I don't know how, I don't even know how a computer works, because I still don't, to be honest. Yeah, don't let that hold you back. Don't let that stop you, because when I came to uni, I had absolutely no idea. As part of software engineering, you learn a bunch of programming languages. So on the screen at the top there, those are either technologies or programming languages that I've learned over the past few years. Yeah, it's kind of crazy when you list it out like that. You don't quite realize how much you learn. But yeah, it's a really cool experience. Some of the other things we do are things like user experience. So your actual experience using an app, we kind of look at and reflect on what makes a good user experience, how you make a good user interface. So that has some really cool design and creative aspects in it as well. One thing that we did this year in one of my papers was we actually made an app. and we got to come up with the idea ourselves. So my group came up with the idea of making Diner, which is like Tinder but for restaurants. So like you sign on to a session with a bunch of your friends, and you all swipe left or right on whether you want to like go to that restaurant or not. And then at the end, it tells you which restaurant you and your friends should go to. So on the screen there, you can see a few images from the app we made. And by the end of the semester, Diner is like a fully functional mobile app. Our lecturer even said, you know, oh, you should put this into the app store. So that was pretty cool feedback to hear. Other than that, you know, if you're more interested in kind of back-end networks and databases, that's also covered in software engineering. Basically, engineering is just a really awesome degree. I have absolutely no regrets about choosing it. I'd highly recommend it to anyone. And I feel like there's certainly something in engineering for anyone. So I'll pass you on to these other girls to tell you a bit more about their specializations. Thank you for listening, guys.
Yeah, thanks, Lola. So that was Lola from software. So now we have Angela with computer systems engineering.
Hi everyone, my name is Angela. I went to Westlake Girls High School in Auckland, and I'm currently in my 3rd year of studying computer systems. Right, what is computer systems? It's basically a combo of electronics and software engineering that were just introduced. Why would I choose to do that? Well, before university, I had never learned any electronics or programming, so I wanted to not only learn theory, kind of like in high school exams, but also like how to make and design real electronics and software, which naturally led to choosing engineering and computer systems as my specialty. Throughout my degree, I've learned theoretical things like more math and programming languages, but because engineering is so practical as well as theoretical, I actually have something to show for it. As you can see on the left, in one of my university courses this year, my team members and I created a budget Flappy Bird using a combination of electronics and programming. Look at it go! I still hate playing Flappy Bird though. In another course that I'm doing this year, using the skills that I learnt making Flappy Bird, we will get to design a robot that can follow along a path, which is done both using software and electronics inside the robot. This combo of software and electronics rather than each on its own is kind of what makes CompSys unique. But on another side of computer systems, currently in one of my courses, we are learning Java, a programming language. But instead of just memorizing code, we are actually getting to create an app for Android smartphones, which is purely a software design-based project. In my case, I'm creating an app to shop for clothes, so it was a great excuse for me to do some clothes shoppings, if I'm to be perfectly honest. To wrap up what I've been saying, all of these projects I have done have been through my degree, despite having no prior programming or electronics experience. So I am sure that all of you could make even more amazing apps and Flappy Bird clones than me if you did something like computer systems. Thanks, and I'll bring it back to you.
Thanks, Angela. So now we have Ainsley with chemical and materials.
Awesome. Hi, everybody. So my name's Ainsley Kemp. I'm in my last year currently of studying chemical and materials engineering. Just a bit of background about myself and why I chose engineering. One of the main reasons I chose engineering was actually this event that we're on right now. At the event, one of the girls told everybody to close their eyes and put their hands up if they hate English, and then keep your hands up and open your eyes and look around. And I looked around and literally everybody had their hand up. And it was quite a difference for me because at my school, a lot of people were going into law and English-based roles. So I felt that engineering was kind of the place for me, and it was kind of like where I belonged. So the fact that I work better with numbers and equations rather than sentences and words was definitely a key factor in deciding engineering. Another reason was I prefer the application side of it. So chemistry was my favorite subject in high school. So I was tossing between a science degree in chemistry or a chemical engineering degree. And I realized that I guess scientists would ask the question why, and they'd delve deeper into that theory and try and discover new things that way. Whereas engineers would ask the question how. So how can we apply that science to the wider world to, I guess, build a better world? And I figured the fact that there's that application aspect to it means that I'd have a more fun job at the end of it instead of, I guess, being more research-based. Another reason, it's great money and you're always got really secure jobs. No matter what specialisation you do, there's a lot of overlap between the specialisations when it comes to jobs. And like you'll always be able to find a job as an engineer. And lastly, because engineering has a huge range of options, I guess like even if you don't want to go into a science-based job at the end of it, the fact that engineering gives you like a very problem-solving mindset means that industry really values us, whether it's in a business consulting role or a journalism role or something like that. We can do anything pretty much. So for chemical materials in particular, it splits off into two areas. One is process engineering, so I guess that's the chemical side of it, and the other is materials engineering. So process engineering, the way I would describe that is it's basically taking a small scale chemical reaction that someone's developed in a lab and turning that into a large scale industrial process and making it optimized and efficient as possible. So the two lower bullet points are kind of, I guess, correlations that I've made with NCEA. I took NCEA, so I don't know what chemistry types of papers were done with Cambridge, but a similar one would be the quantitative analysis internal that you do, I think it was in year 12. Now I know that's the dreaded one with the titrations, but don't worry, you don't have to do titrations as chemical engineers, maybe in like a lab or something. But I was more putting it there because of the calculations. You'll work a lot with mass and moles. And the other one is chemical reactivity and aqueous solutions. Those were my absolute favorite in high school. And it's a lot about looking at equilibrium of reactions and kind of working the reactions to the best way possible. In terms of materials engineering, this is more looking at the deep, like molecular level of chemicals and knowing their properties so that you can kind of fit it to the right application. So an example of a materials engineer would be they might design the materials that a jet plane engine's made of. So if you think about it, it has to require withstand high pressures, high temperatures, high corrosion effects. So you have to make sure that you can use that knowledge and apply it. So similar NCEA papers are the selected elements, that was an external where you kind of learnt about certain elements on the periodic table and kind of talked about what applications are best for that, and the structure and bonding one where you learned about how all the bonds interact. So these are just some photos of like work experience that I've done, just to give you an idea. I won't go into too much detail, but the middle photos are my internship at PPG, where they manufacture paints and protective coatings. So it's a lot of, I guess, being on the factory floor, taking data and looking at how you can optimize that. And these photos on the left-hand side and the right-hand side are from my internship at Mechatronics over the summer. So they manufacture methanol. It's probably one of the biggest chemical plants in New Zealand, and it's just mind-blowing how huge the plant is. People have to like bike ride around to like get to the other part of the site. And on the left-hand side, what I'm looking into is a 1000-degree furnace, which is what my work was around optimizing, making sure we can have the highest efficiencies. So that's just a quick summary. I'm happy to answer questions at the end, and I'll hand it back to you, Un.
Thanks, Ainsley. I also do chem mat, so that's my personal bias. Next up, we have Hannah from Civil.
Hi everyone, I'm Hannah. I'm a Part 4 civil engineering student, and I also study a conjoint with arts, majoring in French. So if you have questions about that, feel free to put them in the Q&A. I'll try and answer some of them. I went to Mount Roskill Grammar, and at school I studied a bit of graphics and painting as well as the typical physics and calculus, but I didn't particularly enjoy calculus, and I was much more interested in the design aspect. So I found that for me, engineering was a way of combining those things, both the creative side and the design aspects, where you work out how things stand up and make sure that your building or bridge is strong enough to last through an earthquake or any type of thing like that. So within civil engineering, there's quite a lot of different aspects. So we have a lot of different electives that you can choose, as well as things that everyone will learn about within civil engineering. So these come from transportation engineering, where you could be designing a big highway, or maybe the city rail link, or even down to things like the management of how traffic lights operate. Then we go through structural engineering, which could be buildings, bridges, as well as hydraulic engineering, geotechnical, which is all to do with soils, foundations, and things like that, as well as environmental engineering, which covers a whole range of things. So these all fit within civil engineering. So I'll just tell you what that means to us as students at the University of Auckland. So while we're studying at uni, we have quite a lot of projects within civil engineering. So we often work in groups, and it's a very collaborative atmosphere, as people have mentioned before. We get to work within teams, and everyone's trying to help each other. So if you don't know something, then there's often someone else who's just happy to help and share their knowledge. So for example, one of these pictures shows a bridge that I designed with a team out of MDF and hot glue. So we had a set amount of time, I think it was 1 hour, to build this bridge, and then we tested it against the whole class. So it was a competition to see whose bridge was the strongest, as well as this famous project in first year, which everyone gets to do, which is the truss project, which you get to build a bridge out of popsicle sticks and tiny little bolts, and then the whole class gets to test it and see which one is the strongest, which is pretty fun. And now that I've made it to 4th year, I got to design this type of portal frame building, which is shown in the bottom left. And so that's a big accomplishment for me that I just finished this weekend. So that's pretty much all I have to say about civil, but please put your questions through in the Q&A. I'd be happy to answer them now or at the end. Cool, back to you, Yetin.
Thanks, Hannah. So now we have Fatima from mechanical, and then it will be followed by Diksha with mechatronics.
Hi everyone, I'm Fatima. I'm a 3rd year mechanical engineering and finance conjoint. I've noticed a few questions in the Q&A about conjoints, and I just want to let you know that they are really manageable, but I can talk more about that later. I went to EGS and I chose engineering because I didn't actually really love physics or maths that much, but I did love design, and we learned a lot of that in graphics, and we learned to use the CAD too. And I also really like the problem-solving ability that we develop as engineers. And this problem-solving ability is what makes us so in demand for doing any kind of job. So with an engineering degree, you can literally work anywhere because people are after the way you think as opposed to the specific knowledge you have, even though that is definitely important too. So what's it like studying mechanical engineering? I've put some photos of some projects I've done, and mechanical engineering is really design based. So we have a lot of design projects and a lot of group projects too, which I really enjoy. I know that's not a lot of people's favorite thing, but they get really, really cool to do together, and you really appreciate the support from team members. In the top right corner, you can see a photo of a car, and this is an engineering club that you can join that's called Formula SAE. And basically you build a car right from scratch and you compete in a competition at the end of the year. So my best friend is a chassis engineer on the team, and she's been helping build the structure out of carbon, which is really cool. The next slide has a couple of videos. So this is a design project that we had to do. And basically we had to build a scale model of a bridge that would open up. So we 3D printed the big cylinders you see, they're called telescoping cylinders, and also laser cut all the beams and everything else. And then on the left is a video of one of my recent design projects. And you had to send a bowl from one end of a box to the other end. And we were supposed to build this in real life, but because of COVID, we've been doing it at home, and we got to simulate it on CAD with all the forces and everything. So the next slide, what kinds of work can you do? I think mechanical engineering is really broad overall, and there are lots of applications of it. So far, I have been able to work in healthcare, so Fisher & Paykel Healthcare, and over there I was an operations engineer, so helping actually produce masks and machines in the factory and in the operations line. And the summer before that, I actually worked to create a chatbot with an AI form. So I think that just goes to show that even with a mechanical engineering degree, you can do things like coding, and it just shows how broad engineering is overall. Yeah, so that's pretty much what I have to say. I'll be happy to answer any specific questions you guys have in the Q&A. Thanks.
Oh, thanks, Fatima. So now we have Diksha with Mechatronics.
Hi everyone, so my name is Diksha. I'm currently in my final year studying Mechatronics Engineering, and I went to Mount Ruskell Grammar School like Hannah. And so I just want to start off by talking about why I chose to do engineering. And like many of the other WEN leaders here, I was really interested in trying to help people and to better the planet. And so I saw engineering as a way to help people through designing, innovating, and problem solving. And I think that's really at the heart of all these specializations we've talked about so far. Engineering is problem solving at the heart of it. And so many of you might be wondering, what is mechatronics engineering? So mechatronics engineering is a combination of mechanical, electronics, computer, and control systems. And the diagram on your right is one that you get shown in one of your first lectures when you start specializing in mechatronics engineering. And what this means is just kind of anything and everything. Mechatronics is often described as the jack of all trades. And so we do projects that involve robotics, that involve design, that involve circuits, that involve mechanics, and so much more. And so the video on the left is a project that we had actually done in our very first semester doing mechatronics engineering. So we're completely brand new to this, and we had to program this robot to pick up this object, go and follow the line, and then deposit the object on the target. And just as a disclaimer, I had never done any coding or anything in high school, and I had only started coding in my first year of uni. And so without any prior background or information on any of this, we were able to do projects like this and so much more throughout my degree doing mechatronics. And then I kind of wanted to touch on some of the other holistic things in my experience studying engineering. So a couple of you have kind of asked, what are the kind of social clubs and things on offer for engineering students? And one of the things that I've been involved in is the Engineering Review. And this is a huge variety show that we put on every year. It's created by the engineering students and for students. And it combines music, dance, acting. We have this really awesome dance show where everyone dresses up in light up costumes, and they turn it pitch black and they dance in the dark. But it's really an awesome opportunity to be creative and to meet some like-minded engineering students. And so that's been a real highlight for me during my journey studying engineering here. And a couple other things I've been involved in, obviously the Women in Engineering Network has been a really cool way to meet other women studying engineering and other like-minded people. And I've also had the opportunity to do a 360 study abroad exchange. So in either your second or third year studying engineering, you can have the opportunity to go and spend a semester studying abroad. And I was really fortunate to be able to go just before COVID started. So I got to spend a semester studying at UCLA in America. And it was a really cool chance to explore, to study classes not on offer here, and to meet some amazing people from around the world, travel, and experience engineering in another country and see what that's like. So these are just some of the things that I think are really unique to the University of Auckland and to my experience studying engineering, which I would really recommend you to do. Back to you, Yuan.
Thanks, Diksha. So now our 8th speaker, we have EJ from BioMedical Engineering.
Yeah. Kia ora, I'm EJ and I'm currently a 3rd year biomedical engineering student. I feel like often when I tell people what I study, everyone gets quite impressed because it has the word biomedical and engineering in it, but often people don't actually know what it actually entails. And it's pretty much just using engineering skills and techniques and using them to solve problems of the human body. So for me, I was always really interested in problem solving, especially the technical side of it, like coding and robotics, but I also had quite a strong fascination with biology. So biomedical engineering was kind of like the best of both worlds for me. In terms of what you study at university, similar to mechatronics, is kind of like a jack of all trades. So you learn a bit of everything. So coding, electronics, data optimization, dynamics, biology, etc. But I think one of the highlights of the course is that each year you have a design paper that you get to do. So have you ever pressed down on your skin and noticed that it changes color? Yeah, so that's kind of, that's actually quite useful for like doctors to check your blood circulation. And so last year, we worked in groups to design a colorimeter, I can never pronounce it, a colorimeter, which pretty much just uses white light reflected on the surface to measure changes in colors in your skin when you apply pressure to it. So I thought it was really interesting because we got to go through the whole design process from like idea generation and brainstorming to actually designing the circuitry, which then actually got sent off to be manufactured. And then we also did like 3D printing for our case, so designing and printing our case, doing a bit of coding, doing a bit of painting, doing lots of lab reports. But just overall, I think it's really interesting if you're someone who kind of likes having a project and being able to have that kind of freedom of designing something and then building it and having like that kind of final result. I noticed in the chat that some people are asking if you have to study biology. No, you don't actually have to study biology in high school or previously to do biomedical engineering, but just bear in mind that if you are considering to do it, there is quite a bit of like biology and medical science involved. So you do a paper every semester. So just keep that in mind while you're deciding on that. Honestly, in terms of like biomedical engineering at the UOA, I think one of the best aspects of it is that you have quite a relatively small cohort. So you have about 25 to 35 people depending on the year. And I'm assuming that your class sizes are pretty similar to that right now. So you're probably thinking like, what's so great about that? But after first year where your cohort's like 1,000 people, trust me, it's quite nice to just have like a smaller tight-knit group of people. It just makes it feel more comfortable, like asking questions or talking. You get to know your classmates and your lecturers pretty well, and like, I don't know, go out to the beach like we did. So I think that's kind of a special part of it. In terms of career pathways from biomedical engineering, you can work for companies such as Fisher & Paykel Healthcare and do research and development. And there's also like a bunch of startup companies that are more focused on like innovative medical devices. So like creating new things like your prosthetics and things that maybe haven't been created before. Otherwise, you can stay on at the ABI, which is the Auckland Biomedical Engineering Institute at the university, and do some more research-based work. So yeah, I really enjoyed my time at so far studying biomedical engineering. So if that's something that interests you, definitely would recommend researching a bit more into it, and hopefully we'll see some future biomedical engineers in here. Yeah, thanks. Back to you, Yuan.
Thanks, EJ. So lucky last, we have Heidi, who does engineering science.
Hey everyone, I'm Heidi and I'm in my 3rd year of engineering science, or EngSci for short. I grew up in Wellington and I did high school in Sydney. Like many of the other girls, I didn't know what to study, but I didn't do physics in my last year of high school, and I didn't know what engineering was really until graduating. But learning about engineering, I love the idea of using maths and science to solve problems and improve the quality of life of society. So after attending the university's Open Day WEN event, I was determined to improve the representation of women in WEN and pursue a degree in engineering. So I did a physics bridging course in summer, and I moved back to New Zealand to study engineering here in Auckland. So engineering science, yes, it's got science in the word, but it is a specialisation of engineering. It was explained to me as using maths and code to solve real world problems. So there are two sub-specialisations. We've got operations research, which is making good decisions through optimization. On the left here is a project I did where we optimized the routing schedule of food trucks to all supermarkets in Auckland based on the capacity and constraints of demand. The other subspecialization is computational mechanics, which is looking at the effects of applying a force to materials. So another project I've done is on the right, which is we modeled how increasing the capacity of a gas reservoir affects the pressure inside and the rate of leakage. NSI and biomedical engineering are actually in the same department. So we're a very small department. There's about 100 altogether. And a lot of the time our courses can be very challenging. So our culture is definitely one of camaraderie. We're all very close and we all work hard and we all help each other. We have a society called BESA, which organizes events for our department, and we have weekly team sport competitions. In second year, we all go on a fun trip together to visit industry and form close friendships lasting the whole degree. Career-wise, NSI is very applicable. You're able to work in a range of roles, from consultancy to software, design, management, and production modeling. So that's NSI. I'm happy to answer any questions about it because I know it's not very well known, but well done and thank you for making it through all 9 specializations. I'll pass you back to Yun.
So thanks, Heidi. Yep, so that is all from our 9 different specializations. We hope that you've learned something tonight, whether it's the variety of pathways that can lead from engineering or even just learning what engineering is. So yeah, so now we have 20 minutes or so to answer your questions that you've submitted throughout the evening. Really sorry if we don't get to yours, but no fear, because you can still email us or look us up wherever. We're all pretty nice and we'll make sure to get back at you. So yeah, I will, if everyone show your little faces, that'd be nice. Hang on, so it's in the, no, it's in Q&A. Okay, so I'll just start with the most popular ones and I'll just chuck it to someone, all right? So the first one is, hi, I wanted to ask about sexism and sexual harassment in engineering, specifically your personal experiences and how the university handles it. So I don't know who to give this to, so put up your hand. All right, EJ, take it away.
I actually haven't experienced any like sexual harassment so far in engineering, so I can't speak on that side. But in terms of like sexism, I think that in general it tends to be kind of like a little bit subtle is the most part. Like you will never, I don't really think that there's like really outright one, like no one comes up to your face and you're like, oh, you're a woman, you shouldn't be doing engineering. But like I think it's just like subtle things sometimes when like they'll be like, oh, you know, you might have just gotten that job or you might have just gotten that internship because they're kind of filling a quota. But I think that, you know, when that's a huge part of what WEN is here to do, like we're really there to try to make a more inclusive environment and raise awareness. And I definitely think it's kind of helping in terms of like the events that we put on about unconscious bias and inclusivity. I'm sorry, I'm really bad at pronouncing things. But yeah, if anyone else has anything to add to that, that's just kind of my experience with it so far.
Yeah, I think we'd be lying if we said that there's absolutely no sexism. It's like 100% like we're all happy-go-lucky. I think the reality of being a woman studying engineering is that you do face discrimination, and that's kind of why we have the Women in Engineering Network. And I think we're, like EJ said, we're doing a lot to provide information and to provide support for people who either have faced it, or to try educate people who may not be aware of their unconscious biases. But yeah, it's definitely something that we're trying to bring about more conversation. And I think it has definitely improved over at least my time studying here, and hopefully more in the future.
All right, I'll go on to the next question. So this is quite a popular one. It's just, what jobs do chemical engineers have? I like chemistry at school. Is there much similarity to chemical engineering? So obviously this one will go to you, Ainsley.
Yeah, so I touched a little bit on like the similarity with what you learn at school, but I guess like seriously we can literally go into anything. If you want to do something that's related to like chemistry, the science, you're looking at, I guess, operating companies, so a chemical plant or factory, and you'll likely be doing, I guess, working with operations, so the people who actually run the plant, make sure that everything's safe, and you might be doing a lot of research and development, so working in labs, looking at how you can create new products, or you could be doing efficiency improvement, so analysing the processes and looking at where there's opportunities to improve. But also there's like consulting and contracting. So that's kind of, I guess, people, like a company might come to you with a problem and say, we have really low efficiencies. We want you to look at our process and improve that. And there's also, someone might come to you and say, I want to build a plant to make this product. Can you design it? And so there can be like detailed design where you kind of look at the deep down chemical reactions of that. But also, I think chemical engineers, we learn a lot of the problem solving mindset, and I think our specialization is one of the most set on that type of learning. So a lot of like companies will just want you for that problem solving mindset. So you could end up in like a business consulting role even, or a role that is more project management for a different specialization. So I'm like even looking for jobs in project management of construction services. So it can literally be anything. It just depends what you like.
Thanks, Ainsley. So this one ties a whole bunch of questions. Is why did you choose UOA for studying engineering? Why didn't you go to UC or Waikato or where else can you go? I don't know. AUT? Yeah, anyone, go for it.
So I found that the UOA engineering program was just the one that was the most advertised to me, and also I just heard it was the best overall. So we had a lot of people come into our school and talk to us about engineering, and I also went to these engineering or future evenings. And we also had Ingenuity Day where I got to come to UOA and actually try some of the specialization stuff, and it really caught me overall. I find that a lot of people want to go to Canterbury because they want to go away from home and live in the dorms. And I actually did that in first year, but I lived in the dorms at UOA. So you can still do that if you do want to move out. And I think overall, Auckland just has such a good engineering program. We have a new engineering building now, all the facilities you could possibly want. And I think it's just a really, really good program overall. Plus you have WEN, so why not Auckland? I mean.
Thanks, Fatima. This might be a question that a lot of high school kids might be a bit anxious about, which is the workload of an engineering conjoint manageable? Would having 2 majors and a degree in a conjoint alter this much?
Oh,
Go, Aditi.
I was just gonna say that I think it's very manageable, and I think the best part about it is that you design your degree so you can go at the pace that you really want to. So if I know that a semester is gonna be really full on, I'll like select papers, or I'll select fewer papers to complement it. So you're very much in control. And the second thing I'd like to say is that I do a science degree, and I actually switched from an arts degree to a science degree, and I'm still finishing on time. So I feel like it's not as hardcore as people might make it seem, but you can just give it a go, and then if it's too much for you, you can drop it. It's not like you have to do it and you're going to be forced to finish it off.
Yeah, I'd just add to that as well, as is quite common to start with a conjoint, and you can try out different things and see how it works for you. And then if you're finding it too difficult or something, you really haven't lost much if you decide to just stick with one of the degrees later on, as the engineering component of the degree is like front loaded. So you get a lot of progress on your engineering degree, and you would only dedicate a small amount of time to your conjoint degree at the beginning and a lot at the end. So even if you stop after first year, second year, or third year, you haven't really lost that much at all. So if you're interested, I'd recommend you can give it a go, and if it doesn't work, there's not much to lose.
Yeah, and the last thing with two majors, it doesn't really matter. You can go along as you like and like drop a major, pick up a major, and it's really not like that much of a workload, because like Hannah said, you do your conjoint part at the end of your degree, so like in your last year. So there's usually like 1 or 2 papers difference.
So a question for Lola and Angela. What is the difference between CompSys and software engineering?
Oh, so I attempted to answer this within my spiel. However, what I would...
Is it just me or did she disappear? Alrighty, well, I'll take over here. So I'd say the main difference between software engineering and computer systems engineering is that software is focused on like basically the coding, and you kind of do everything on a computer, whereas computer systems engineering, you do software and hardware. So hardware are like the physical components of electronics, essentially, if that sort of helps answer the question. I don't know much about computer systems, but software is really fun.
Yeah, I don't know much about CompSys either, so I can't answer that, sorry. Another question is, how much of NCEA physics and calculus do you use when you study engineering? Let's broaden this. Let's say, was the transition from high school maths and science difficult and then you go into university later?
I don't know. For me, I personally felt like it was just different. I wouldn't say it was harder or easier, because some aspects are harder. For example, I found math in university a little bit easier than I did in high school, but I know lots of people didn't feel that at all. But I thought that the physics and the mechanics were a little bit harder for me. So I think it really depends on you, but it is quite different from what it is in high school, and the way they teach it and the amount of content there is a bit different.
Yeah, I'd like to add to that. I mean, I bet some of you are thinking about taking a gap year as well. I took a gap year, and I was a bit worried about, oh, am I going to be like one of those dumb kids? Like, I don't remember my physics and maths, and I don't really think it's going to be difficult when I go into first year. But trust me, no matter how traumatizing your maths classes, you seriously will not forget your maths. I mean, like differentiation, integration, it's basically stuck with you. You might forget bio, like what is a mitochondria, but maths you seriously won't forget. And honestly, when you go into university, they start from the basics. You have, for example, leading from NCA, you did 1 electricity paper and you did 1 mechanics paper, I think. And you actually have 2 papers like that in first year engineering. You do 1 mechanics and 1 electricity, and they start from the basics. Like for electricity, you learn what a voltage is, you learn what a current is. If you didn't pay attention in class or in high school in general, I honestly don't know what voltage was until I went to university. So yeah, it's seriously not a really big transition, but yeah, it's just very different, a very different flavor of lecturing and learning. And yeah, it's quick, it's quite good. You'll pick it up super fast. Another question is, how difficult is it to get work experience and internships? Does the university support you on this?
I can answer this one. So I would say the support is so big for getting this. And I think another thing to consider with getting internships and work experience is because it's a requirement for us to get 800 hours work experience in order to graduate. There's a lot of companies, engineering-based companies, that make internships and those roles available for you. But we also have like a lot of support within the university. So we have an employee liaison under the Faculty of Engineering who will literally spam you with emails. It's great though, I love them. And I've gotten like all my opportunities through that. I've gotten 2 internships and a scholarship through that. And it's just so helpful. Like, I guess if you've already got one, maybe you might want to delete the emails, but it's really helpful because there's a lot of companies you just don't know about, and they tend to contact him and he'll come to us. But there's also the CDS within the university. So I think that's called Career Development and Employability Services. And so they do a lot of CV checks, practice interviews, career development workshops. They literally do so much for you. So I don't think you should be worried about finding work if you do an engineering degree.
Thanks, Ainsley. Another question is, how difficult is it to get into biomedical engineering? Or could you please explain how difficult it is to get into your first choice of specialization?
Well, yeah, I think I've answered it a little bit, but for all specializations, it just depends on your GPA from first year, and it kind of like entry requirements change every year depending on how many people want to get into each specialization. So one year, if like a lot of people wanted to get into biomedical engineering and they all had really high GPAs, it might be really hard. And then another year, if not that many people were keen, then it will be a lot easier to get in. So there's no strict GPA requirement, but the only advice is just to work hard in first year and try to do the best you can. It tends to be like a little bit more difficult than papers such as civil, just because it's like such a small cohort. But yeah, I think just try your best in first year. I don't think it's that difficult. I think yes, but yeah, I don't know. Sorry.
Can I just add to that? Yeah, I had MSci as my first specialization choice, and I didn't actually get in. So I was doing biomedical. And after the first semester, I was able to reapply and transfer for the second semester. And none of the courses I had done actually, they were still counted because they're very similar. One paper was just made an elective. And I know people that came from civil into MSci. You can change. You're not completely stuck as well.
I think we have enough time to answer 2 more questions. So. Okay, what's the culture like at uni? Is it really different from high school? How long are the lectures, and do you have to go to tutorials and stuff like that?
Yeah, so I guess culture-wise, I think it's what you make of it. If you're outgoing and if you put yourself out there, it can be a really awesome and really cool experience. I think there's just such a wide variety of clubs and groups that you can get involved with, which I would really, really recommend you do. It's just I think engineering especially, the culture is quite cool because you have your specializations in your little cohorts. And so it really feels like a family. I know other degrees, often like commerce or arts, because you have your own papers that you do in your own majors, it's quite hard to get that cohort feel. Whereas for me in mechatronics, all my papers till my 4th year are actually all fixed for me. So I don't have any electives, which means I know most of the people in my cohort, we're all really good friends. We're all worked on projects together, and it really means that like we're just one really big family, which is something I really love about the engineering degree and the experience.
Thanks, Diksha. For the last question, I'm going to ask, how has being part of WEN enhanced your experience at university? take it away.
No, Lola, you can go first.
I feel like we
Everyone's
all
too
love-
keen. Everyone just loves when.
Yeah, we all love when.
I'll give a quick answer though. For me, when has just been awesome. Obviously, I moved up from Dunedin, so it was difficult for me coming to a new place, and I'm sure Heidi can relate to that as well, coming all the way from Australia. When was a great way to meet people. It was a great social kind of thing. And it's really cool because you have people that you can relate to, because obviously being in engineering, it is male dominated. There are a lot of boys, so it's nice to just hang out with the girls sometimes.
Yeah, just adding to that, personally for me in high school, I was really quiet. And I feel like because of when, it really developed my personality, and I don't know, it really broke me out of my shell. So just going to all the events and being like really proactive helped me personally a lot, feel really comfortable enough to speak. So yeah.
Anyhow, I think that's all the time we have today. Thank you so much for attending.